So when I graduated in 2007, I then did a postdoc also at Cal in neurobiology in Frank Werblin's department. And there I learned various aspects of electrical engineering and how it applies to vision and retinal information processing. After my postdoc, which was 4 years long, I then wanted to pursue starting up my own venture. And I feel that I really had the foundation from a diverse background in being able to communicate with a wide variety of scientists that has helped me tremendously in being able to start up my own company and discuss problems, whether it's with engineers, lawyers, accountants, you name it. Being able to communicate effectively has helped tremendously with starting my own company. And I did that through the QB3 East Bay Innovation Center startup program, where you're able to essentially take an idea and develop that idea into a business. And here we're at Spiral Devices, and our goal is to develop gene delivery devices that will allow for other researchers to do their own explorations into the genome, into developing therapies for degenerative diseases or other sorts of diseases. We're particularly interested in neurodegeneration, so our devices are geared towards that. A wide variety of things could be done with these tools, and QB3 has been instrumental in fostering that type of communication between researchers here in industry as well as our past colleagues at Cal. And there's still a dialogue that goes on between me and my past professors and other students that has really helped me to expand my scientific background into a startup company environment.
So I graduated from the Vision Science program in 1997 and am now an associate professor here at Cal, as well as the University of California, San Francisco Proctor Foundation. And although I originally came here to Cal to gain additional clinical training, it wasn't long after I arrived that I realized the value of the Vision Science program in helping me to ultimately secure my career goal of an academic position. So after many, many years of doing clinical research, I was able to finally pursue my research interests from a basic science perspective. And I really feel that that's what makes Cal so unique, in that the expertise on this campus is so broad and so diverse. And when you couple that with state-of-the-art core facilities and all the latest technology, it really allows one to study vision-related disease from a human to a cellular level. And perhaps equally important is that I was able to gain the mentorship of several internationally renowned scientists here at Cal. Each one of those mentors has played an essential role in helping to guide me to my next career and my dream job in academia. So now every day I get to go to work and be a clinician, a scientist, and a teacher.
As a vision science grad student, I had the opportunity to intern with several companies in Silicon Valley. The first one, I was developing a 3D display system using a new technology. In the second, I had a chance to work for a medical device company developing a 3D surgical imaging system. And that surgical imaging system is in wide use around the country. There's over 1,000 of those display systems that are spread around the United States and the world. After graduating, I joined a semiconductor, MediaTek USA. I worked on developing the camera systems that go into cell phones. Since then, I've joined Samsung Electronics R&D division, where I'm working on developing new display technologies that are going to become widely used over the next decade. So, semiconductor companies all around the Bay Area are working on developing new electronic devices. There are TVs, computer monitors, new camera systems, cell phones. All of these efforts are going to require creating beautiful imagery. And one of the ways that these companies make their decisions about how to properly balance resolution, the color vividness, all of these companies are able to create such stunning images in their products is by understanding the concepts of vision science and applying them to their designs. They're making trade-off to reduce costs, to boost brightness, to enhance color. One of the ways that they do that is by interacting with the vision science department and finding out what types of changes are going to be perceptible and what's not. They're looking for the line between the invisible and the invisible, and that's where we help them find.